From North America, from Sweden, Finland and Norway, as well as other countries, come shiploads of wood pulp for the Aylesford paper mills. At the waterfront, the 400-pound bales of pulp are unloaded by overhead stacks or direct to the mill. Main raw material for all papers manufactured at Aylesford, and all of it has to be imported. Many types of ground wood and chemically treated wood pulp are stored here, each kind suited to particular papers. More than 250,000 tons of pulp are handled every year at this wharf, and approximately 1 ton of pulp goes into every ton of paper. Thousands of tons must always be held in stock, lest shipments are delayed by ice or storm. Some bales are used immediately. For example, within hours, this very pulp, converted into newsprint, may be on its way to the newspaper presses. To produce the stock of pulp shown here, nearly 4,000 acres of pine or spruce will have been felled. The many uses to which paper is put and the different qualities it must possess for different jobs make necessary a variety of treatments and a variety of ingredients in addition to wood pulp. China clay, for instance, is used in a number of papers. So from Cornwall come these coats, each carrying up to 350 tons of clay direct to the mill. The clay is unloaded to bunkers where it is stored ready for use. Added to the raw material mixture or furnish of newsprint, China clay helps to provide a smooth surface to the paper as well as making it ink receptive. It is also used in the manufacture of coated art papers, contributing to their glossy appearance. Altogether, more than 13,000 tons are handled every year. Yet, clay is only one of the many substances which may be added to give papers special characteristics. Coal is a vital raw material for the paper manufacturer. Approximately 1 ton of coal is consumed during the manufacture of 1 ton of paper. At Aylesford, therefore, over 250,000 tons of coal are needed in a year. As in so many industries, coal is the primary source of power. Coal turns water to steam, which is then used to drive the turbines, enabling them to generate electricity, which in turn drives the paper machines. Exhaust steam from the turbines also provides heat to dry the paper during the manufacturing process. Coal is fed mechanically to these huge boilers. A constant watch is kept on the automatic controls to ensure that fuel is used with the maximum efficiency. Steam from the water evaporated in the boilers drives these generators. fresh water is needed. Thousands of gallons for every ton of paper, and much of it comes from the company's boreholes. The paper-making process begins with the bales of pulp. Wire bindings removed, the bales are conveyed to hydropulpers. Here the pulp is disintegrated in water. The wood fibers, separated by the action of the hydropulper, form the stock from which paper is made. The type of pulp used and the treatment given determine the paper's quality. Besides the pulp, size, china clay, dye, alum and other materials may be added at this stage to obtain special characteristics or colors in the final paper. 4 tons of pulp can be prepared by this hydropulper in under 30 minutes. The stock then passes to beaters or direct to refiners, which complete the preparation. From there it is pumped to the paper machines. Automatic regulators ensure that the stock reaches the machine at the required consistency. After screening, the mixture is evenly projected through a metal slice or lip onto a fast-moving fine mesh wire. The stock starts as more than 99% water. Much of this water is drained away through the wire and more is then sucked away by vacuum boxes. The fibers, meanwhile, bond together to form paper, which is now rapidly dried by steam-heated cylinders. The wet web of paper is carried by felts as it passes to the drying section of the machine. This machine is making glazed tissue paper, and the one vast cylinder both dries and glazes the paper. At the end of the machine, the paper is reeled up round a bar or shell. The machine never stops. Even when a full reel is removed, paper continues to run round a new shell. The varieties of papers made at Aylesford calls for a variety of machines, and for machines capable of a wide range of production. These are electric motors which drive a giant newsprint machine. "300 feet long and making 15 miles of newsprint an hour, this is one of the largest machines in Europe. Crews of 6 working in 8-hour shifts keep it running night and day. Only a minute and a half passes from the projection of wet stock onto the wire till it is reeled up as paper. Presses remove more water from the paper before it passes to steam-heated drying cylinders. Felts keep the paper in close contact with the cylinders, which evaporate the moisture remaining in the paper. The last cylinder is a cooling one. The paper then passes through a stack of rolls called a calendar. This imparts a slight gloss to the paper before the final reeling up. Every 30 minutes or so, a reel weighing about 4 tons will be completed. Samples are taken for testing from every reel coming off the machines. Each sample cut to a set size is weighed on special scales. This strip of paper of a standard length and width is tested for tensile strength, the breaking strain being measured and recorded. This test is designed to measure the tearing strength of certain classes of paper. The bursting strength of paper is recorded here. Though different papers undergo different tests, most of them are subjected to this one. Testing is very thorough, and in most tests, several readings are taken and the average recorded. Here, the paper is undergoing the Cobb test for sizing. This is a way of measuring the water resistance of paper based on the amount of water absorbed by the paper in 45 seconds. After weighing, the paper is immersed in water for the necessary period. It is then re-weighed to calculate how much water has been absorbed. For many types of paper, it is essential that they should possess some resistance to water, and this is generally achieved by adding size during the preparation process. Some papers, as we saw, are loaded with other materials such as china clay. This test is designed to determine the amount of loading in the paper. A weighed amount of paper is burnt in a muffle furnace at red heat. The ash is afterwards weighed, and from this the percentage of loading in the paper can be calculated. Results are dispatched by pneumatic tubes. After removal from the paper machine, the newsprint is passed to a super calendar. Here, a smooth finish is given to the paper by running it between alternate steel and fiber rolls. The paper has already passed through a calendar stack on the machine, but now a final polish is given, leaving a receptive printing surface. Good printing properties and sufficient strength to avoid breaks on the high-speed presses of the newspapers are two prime requirements of quality newsprint. To start the super calendaring process, the paper is threaded by hand through the motor-driven rollers, which are later speeded up. At the top of the calendar, a suction box holds the paper in position and removes loose paper fibers. When it has been threaded through the rollers, the paper is wrapped round another reel bar. Here the paper winds up after passing through the rapidly revolving rollers which impart the polish. From the super calendar, the paper is passed to the reeler. Here it is slit into smaller sized reels according to customers' requirements. To achieve this, the paper is run over slitting knives, which can be set any distance apart. It is on the reeler also that the paper is joined wherever breaks have occurred during the paper making process. These breaks are marked as they occur, and the reeler crews splice together the broken edges. The broken edge of the paper is squared off and trimmed. After trimming, the two edges of the paper are then spliced together with a strip of adhesive tape. The tape is then ironed to seal the join. It is essential that the join be left strong and smooth, or the paper would tear in the printing presses. For use on high-speed printing presses, it is vital for the paper to be of the highest printing standard, and also for each reel to be perfect and free from any weaknesses. Great care is therefore taken over these joins. After the break has been spliced, the machine is started up again, slowly at first to avoid a sudden strain. As the paper runs through the reeler to wind round another shell, it passes over slitting. These circular slitting knives are set according to the width of paper required. When the bar in the center is removed, this reel will fall apart into 4 sections. Sometimes the paper is ordered in sheets, and then the finished reels are passed to the cutting department. This cutter can handle up to 8 reels at the same time. They are passed under a circular slitter, which cuts them to the required width, before they reach the revolving chop knife, which cuts the reel crosswise. This knife is geared independently of the rest of the machine, and its speed can be varied to give different lengths of sheet as required. The finished sheets are passed onto a conveyor belt, which has both fast and slow-moving tapes. The difference in speed allows the sets of sheets to lap onto each other, giving a neat and regular stack of finished sheets. These sheets of paper, which you see coming from the cutter, still have to be checked in case they are not up to standard. Women become adept at spotting a defective sheet of paper, one job which no machine can do. They are very quick at counting, too. When the sheets have been sorted, they are counted out into reams. A tag with a girl's number is slipped into each set for subsequent identification. The counted reams are set to one side, and then they are ready for the packers. For this job, the men work in pairs. Each team wraps the paper sorted by 4 girls. There is a real art in so handling the paper that it lies neatly and evenly when it is packaged. Special care has to be taken over the corners of the reams, as these are the most vulnerable parts in transit. Gummed tape neatly finishes the parcel. The major part of the paper produced here is dispatched in the form of reels, ready to be converted into a variety of paper products. Reel wrapping varies to customers' requirements, but care has always to be taken in protecting the edges and ends. The dispatch of paper is a business in itself, and since upwards of 4,000 tons are made at Aylesford every week, the finished paper often has to be stored in stockrooms. The finished paper is delivered all over the country by Reed's own transport fleet. Specially designed loading docks with traveling cranes make for quick and easy handling of up to 700 tons of paper every day. There are many lorries of different types and sizes, some of them capable of carrying up to 14 tons. More often than not, it is loaded with newsprint for the national and provincial press. Sometimes there are specialty orders like this 16-foot reel of craft going to Italy for use in a large electric transformer. A reel as long and as heavy as this needs very careful handling. Small, by comparison, are the reels of newsprint for export, but special care is taken in packing them. Much of the paper exported by Reeds goes to Australia and New Zealand. So the tree from Scandinavian or Canadian forests may end its travels as a newspaper in a Sydney or Auckland home. But while much of the paper is dispatched far afield, much remains at Aylesford to be converted into a variety of paper products. Adjoining the paper mills is Medway Paper Sacks, a company of the Reed Paper Group which manufactures all types of multi-wall sacks from paper supplied by the mills. On this 4-color pre-printer, customers' designs and trademarks are printed on the back, front and side panels as required. Reels of paper fed through these machines are rewound after printing and stored for subsequent use as the outer ply of the finished sack. On this tubing machine, reels of paper are being formed into an endless tube and cut into predetermined lengths to make the body section of each individual sack. From the unwind end, the sheets are brought together in a cross-pasting section where lateral gluing provides for the perfect formation of the end closure. Here, the edge of each separate ply has been glued to provide strong side seams, and the sheets are being formed and folded into their final position. After being cut, the tubes are ejected onto a moving take-off conveyor for stacking. Other larger tubing machines are designed to manufacture tubes containing as many as 6 plies, and in addition to kraft, bitumen laminated, plastic impregnated and other papers are used. This machine is equipped with a built-in printing unit, which enables both operations to be carried out simultaneously. Tubes manufactured on these machines are specially designed to contain powder and granular substances of all types, ranging from cement, lime and stone dust to foodstuffs, fertilizers and chemicals. Conditions of temperature and humidity are taken into consideration in assessing the final quality of sacks for each commodity, and a wide range of protective papers and adhesives is used to ensure the safe storage of materials over long periods. Sacks for granular fertilizer, for instance, are made from mixed plies of wet, strength, sized and bitumen laminated papers. They are capable of withstanding without ill effect months of storage under the most rigorous climatic conditions. Units like this are producing every hour many thousands of sacks of all sizes and qualities. After this operation, the sacks are stacked on flat boards and moved by electric trucks to the finishing departments. In certain cases, printing is not carried out until after the tubes have been prepared, and these machines are used primarily for small orders requiring a number of minor design changes. Some designs involve the use of as many as 4 different colors, and the sacks are printed with detailed instructions concerning the use of their contents, which are vital to the consumers. This machine forms closures at both ends of tubes. One end of each tube is completely sealed, and the other end is formed so that an aperture of predetermined size remains through which the sack can be filled. These automatic valving and bottoming machines convert the open tubes into valved sacks. They perform an intricate series of operations such as folding, gluing, and making strengthening strips and valve sleeves. The size of the valve aperture varies greatly according to the contents of the sack. For example, the aperture required for sacks containing cement is very much smaller than for those containing granulated sugar. The final strength of these end closures must be very great to ensure that during the filling operation there is no danger which might result in a leakage of the contents of the sack. Valves of this sort close automatically when the sack has been filled. Some sacks, mainly those required for products to be exported, are wire-stitched at both valve and bottom ends, and heavy quality sacks stitched in this way safely carry their contents to destinations all over the world. An operator engaged in this work can stitch several hundred sacks an hour. Sewing is another method used for closing the ends of tubes, and most sacks treated in this way are for granular substances of all types. Samples taken are tested for strength to ensure that no defects have occurred during manufacture. All raw materials are also tested before use. The finished sacks are now packed ready for dispatch, and every day large numbers of them leave the factory on their journey to places all over the country, where they will be filled with commodities of every description for distribution to consumers in a wide field of industry and agriculture. New developments are frequently taking place in the multi-wall sack making industry, and no effort is spared to make this Reed Group product the finest in the world. The company also manufactures machinery for filling, sealing and handling paper sacks. Here is a sample of their work. The special filling spout ensures controlled fillings of the sack and eliminates dust. Press the button and the sack is automatically possed or smacked to force out surplus air. As it passes, the sack itself operates this automatic sewing head. On the conveyor belt, the sack is pressed and flattened till it has acquired the ideal shape for stacking. As a result, the filled sacks no longer look like this when piled. Instead, they are stacked the Medway way. Another converting factory in the Aylesford Group is that of the Medway Corrugated Paper Company, making corrugated fiberboard cases. Its paper store contains many reels manufactured in the Reed mills. The paper passes to these double backing machines. Here, reels of straw paper are corrugated and face kraft liner boards. Silicate of soda is used to make the liners adhere to the corrugated paper, thus completing the formation of the corrugated board. The board is then dried by passing over a steam-heated metal bed and under felts. The effective adhesion of the liner is ensured by the slight pressure of the felts. The continuous length of board now has its edges trimmed. It is also slit to the requisite width and is scored to facilitate folding. The board is then chopped to the length required by the particular order. The resulting material is light but strong, making an ideal packaging medium. As the boards reach the end of the machine, they are collected and stacked on stillages. They are then stored prior to further machining, each load being labelled with details of the order for which it has been run. The boards are now ready for conversion into cases which may package such diverse items as television sets, canned foods, crockery or bicycles. A special department designs the different cases necessary to give each article the maximum protection. Boards are fed into this printer slotter when the machine has been set to the specifications of the particular order. Not only will it print a two-color design on the board, but it is also capable of slotting, trimming and scoring the board to form the standard type of case in any required size. It can, however, only deal with the less complicated designs. The board is now passed to this flap cutter, which trims the flaps to ensure that they meet accurately when the case is assembled. The machine can easily be adjusted to trim flaps of any length or width. Cases of more complicated shape have to be cut out on this power press instead of on the rotary machines. This press can cut and score the board to produce a case of literally any shape, and it is also capable of cutting instantaneously several similar cases from a single board. Waste trim is cleaned off by hand. Smaller sizes of board are machined on this faster working press, which has an automatic feed. After coming from the printer slotter or the press, the cases are stitched. This is the final operation before packing and dispatch. While the majority of cases are stitched, they can instead be taped or glued if the customer so desires. In some instances, the cut board comes off the machine ready for dispatch and can be assembled merely by folding and interlocking the flaps. Stitching is, however, the normal practice. This huge case will be used to pack a complete bicycle. Most of the bicycles in these cases will be exported to America, where the protective qualities and attractive appearance of this type of case have a great appeal. This semi-automatic stitcher is fed by hand from boards kept at a constant level. After stitching, the cases are counted as they pass a photoelectric cell and are automatically released in batches of the required number. This fully automatic machine not only feeds in the boards, but folds them over as well as stitching them. Instead of being stitched, cases can be finished by taping, as this machine is doing. As the tape dries, it is also pressed to seal the joint. Coming off the conveyors, the cases are examined, counted, and stacked. Internal fitments, such as pads or partitions, may also be needed. Here, boards are being trimmed and cut, ready for conversion into filler pieces, division pieces, or pads. Smaller-sized boards are slit on this type of automatic machine. The fitments, which will be made from them, will give yet more protection to the contents of the cases for which they are designed. The pieces of board are now slotted, ready for assembly as interlocking partitions or divisions. When fitted together, the slotted partitions will provide protection for glasses, jam jars, valves, Easter eggs, and similar articles. Machines are also used, but only for straightforward jobs like this assembly of partitions. All fittings, as well as the boxes, are suitably packed to ensure safe arrival at their many destinations. We have only seen part of Aylesford's varied production. From the paper mills come thousands of tons of paper for well-known newspapers and magazines. Varieties of toweling paper, cellulose wadding for handkerchiefs, toilet rolls, and so on. Tissue paper for wrapping is also produced, as well as tons of base paper for wallpaper, ready to be printed and embossed with a variety of gay patterns to brighten many a home. Ticket reels and crepe paper, fiberboard for suitcases, and glazed and unglazed craft wrapping papers in various colors. Craft and sulfite for paper bags. Craft for conversion at Aylesford into multi-wall paper sacks, and many other varieties of paper, including some for Medway's cases. These cases are of every size and shape, each tailor-made to give perfect protection to an infinite variety of articles. The skill and ingenuity of the packaging is typical of all the work of the Reed Paper Group, where the care of trained craftsmen is allied to the productivity of modern machines. Aylesford, which we have briefly visited, is only one part of the group, although it is one of the largest mixed mills in the world. In all the vast scale and scope of its industry, quality and quantity go hand in hand, the results of accumulated knowledge and continuing research.